Hi, so we're going to be answering a question of how to solve for A, B, C, and D, given this information right here, f0 equals 1, f prime of 0 equals 6, and our critical points being x equals -1 and x equals 2. Let's begin. Oh, that's the wrong color. All right, let's begin. So, here's the thing about math, is that we're given a couple clues. First of all, f of 0 equals 1. And then f prime of 0 equals 6. So we know that if we have an f of x, I'm going to write that down here, equals ax cubed plus bx squared plus cx plus d, then we might need to have an f prime of x. And how we do this is we derive each element individually. And so the derivative of ax cubed is going to be 3 times a times x to the 3 minus 1, which is going to be 3ax squared. Following through with the same process, we have b times x squared, so that's going to be 2 times b times x to the 2 minus 1, so 2bx for this term. Then we just have this x right here, so we just leave this as a c, and since d is a constant, it becomes 0. All right, f of 0 equals 1, and f prime of 0 equals 6. Already, if we have f of x, or f of 0, being equal to 1, then we plug in 0 for all these x's, and we're left with f of 0 just being equal to d, which is also equal to 1. So d equals 1. Now, f prime of 0, what we have here is a 0 throughout here, and we're just left with c equals 6. Pretty simple so far. I'm going to change colors right here because now we're going to get to the trickier parts. All right, so what we got right here is this. And up top here, I'm going to write down our critical points. So our first critical point is x equals -1. I'm going to write down the second one. What this means is that our derivative, f prime of x, is equal to 0 or extends to infinity at x equals -1. So f prime of -1 is equal to 0 or infinity. We're going to assume that's 0 because if any one of our constants extends to infinity, this would just be a little implausible. So just for the sake of the question, let's assume that the critical point happens at 0. So the derivative at -1 is 0. So f prime of -1 is equal to 0, which means that 3ax squared plus 2bx plus, what was our c value? If we have -1 squared, then we get 3ax squared, 3a1. Then we get plus 2 times b times -1 minus 2b. Sorry about that, I had to backtrack. And then our c value was 6, so we're going to add 6. And this is equal to 0. Cool. Now we have f prime of 2. And what we have right here is that this is also equal to 0. Same principle, right? We don't want, right, 12a plus 4b plus 6 extending to infinity, right? That means that like either a or b extends to infinity, or just a extends to infinity, just b extends to infinity. It's just, again, implausible. So we're just going to assume that a and b are finite and that f prime of 2 is 0, right? Critical points when the derivative is 0 or extends to infinity. And so for this one, we got 2 squared right here is 4 times 3. We got 12a. We have 12a plus 2 times b times 2 plus 4b, and then plus 6 is equal to 0. Here's the thing. This is just a question of constants. And so we're going to set these two equations equal to each other. And what we find is that 3a minus 2b plus 6 is equal to 12a plus 4b plus 6. We can cancel out the 6's. What else should we do? I'm thinking, let's add 2b on both sides. plus 2b. And then I'm going to subtract 12a from both sides. So subtract 12a, subtract 12a. This cancels out. So this way we get negative 9a is equal to 2b. Sorry, 6b. Make sure you do it right. And so this leaves us, we're going to solve for b, right? This means that we can divide both sides by 6. We get negative 9/6, or what can be reduced to negative 3/2 a. And so knowing this, let's plug back in. Let me change to a different color. I don't know why I did that right there. All right. Now, let's go back up. 3a, now let's do, yeah, I think 3a. We have 3a minus 2 times negative 3/2 a is going to be minus negative 3a or plus 3a. So we're going to do plus 3a plus 6 equals 0, or 6a plus 6 equals 0. We're going to subtract 6 from both sides. We're going to get 6a equals negative 6, divide by 6. A equals negative 1. All right, that's pretty cool. And we're running out of room, but we should make it. What we're going to do next is just plug it back into the same equation. We're going to get negative 3 minus 2b. We're going to use the f prime of negative 1 equals 0 equation, or f prime of negative 1 equation. We're going to do negative 3 minus 2b plus 6 is equal to 0. We're going to combine like terms. 6 minus 3, it's going to be 3. We're going to add 2b to both sides. Then we get 2b is equal to 3. So from there, divide both sides by 2. B equals 3/2. Look right there. We're able to solve for A, B, C, and D. And down here in our final little color right here, we have A equals negative 1, B equals 3/2, C equals 6, D equals 1. And last but not least, let's write down our new equation, or the same one, but this time with the constants realized. F of x equals negative x cubed plus 3/2 x squared plus 6x plus 1. And that's essentially our answer. A, B, C, D is our answer, but f of x gives us that. All right, hope you learned something new.